This video will take a look at conditional probabilities with a Venn diagram and the independence of two events. So, conditional probability, as a reminder, is the probability of an event occurring based upon a prior event occurring. In a Venn diagram, it may not seem that one event has occurred before another. So let's figure out how to actually calculate a given situation. So we're going to say the probability of A given B. This means we want to know the probability something is in A given that it has been in B. Well, we remind ourselves that we find the probability of the intersection of these two, so the probability of A intersect B, and we divide that by the probability of B. On a Venn diagram for this particular problem, we can see that the intersection is 0.1. Now, when we come to the probability of B, we have to remember that we're looking at all of circle B. So we need to add together the 0.1 and 0.4. So the probability of B is 0.5. And this becomes 0.2. So the probability that something is in A, or occurs with event A, given event B occurred, is 0.2. I'm going to move on to independence of two events. Two events are independent if the occurrence of one has no effect on the likelihood of the other occurring. Well, let's take a look first at an example before we jump into these formulas. So, example, using a standard deck of cards, okay, so that has 52 cards, and we know half of them are red and half are black. Are the events of drawing a red card and then drawing a black card independent if the first card is not returned to the deck prior to the second card being drawn? Well, some of you may have enough experience with cards to be able to answer this right away. If I have a deck of cards that are in my hand, there's 52 of them there, and I draw a card, and I see, oh, that's red, and I put it to the side. I don't put it back in the deck. Now I know that there's only 51 cards in the deck, and no longer are half of them red and half of them black, because now there are 25 red cards and there's 26 black cards. So drawing a black card on my second time has a slightly better chance because there's 26 of them in there. So these events are not independent. And now I'd like to take a look at the formulas. Coming back up to the formula, it says, if you know the probability of the two events intersecting is equal to the first event multiplied with the second event, then you know that they are independent. So if the intersection of the two events is equal to the probability of each events separately and multiplied together, then we know they're independent because one event is not affecting the likelihood of the other. It doesn't say that the intersection is 0. It does say that the intersection is equal to the probability of E multiplied with the probability of F. This is only true when the two events are independent. Let's move on to the probability of E given F. So this second line is also allowing us to determine if two events are independent. And notice this "and" clause in the middle. So both of these equations must be true for two events to be independent. The probability of E given F must equal just the probability of E. And the probability of F given E must equal just the probability of F. I'm going to use this second set of equations to show us that in fact our example that we were working with is definitely not an independent situation. So remember, we were looking at the probability of a second card being black given the first one was red. And if it were independent, then we would know that that's equal to the probability of a card being black. Okay, so we go back to the situation where I have a deck of cards. I've taken off one card and it was red, and I've set it aside. So I know that I have only 51 cards in my hand. And if my second card is drawn and it's black, it's 26 out of 51. That is black given red. Now we go back to the very beginning of my deck of cards. So all my deck is put together. I have 52 cards, and I know that 26 of them are black, or I know that this is a half. We know that the fraction on the left, 26 over 51, is not equal to a half. So we know that this situation is not an independent situation. They are dependent.